much, Hannes. Very good afternoon to everyone here, and very good morning to you, Hannes. So you have to tell me when Rainer is ready before I go into my presentation. So just quickly, this is one of those webinar series that we are commencing due to the COVID situation. We would have had physical face-to-face events otherwise that we do at least twice a year. So this year, since we are all in the lockdown and we are not able to meet face-to-face, this is the next best alternative. So Hannes, is Rainer ready to talk?
Absolutely. Rainer, are you there?
Mute now. Hello, everybody. This is Rainer Horn. I'm the Global Coordinator for GNSS.asia. Thank you very much for joining us this afternoon, India, and this morning, Europe. We're very delighted and we're actually astonished to see so many people joining from around the world. And special thanks to our Indian team and to Professor Anindya BOSE for lecturing us and to arrange this. And thank you, Hannes, for organizing. So without further ado, I think we should get into the program.
Thank you, Rainer. Yes, yes, it is like I said, right? It's today the best alternative because we are not able to meet face to face. So quickly, we'll get started by talking more about what our program is all about. What is GNSS-asia? It connects actually the European as the GNSS in the sector, connecting with about the whole of Asia, about 7 economies, and today it is expanded to Australia and Singapore as well. So what we have done over the years is what you're going to see in sometime in the month of November of 2011 is when we got started, and it is now almost 10 years after we started, and you can see what has been achieved in the program so far. So as you can see, these are the 3 pillars. We facilitate industrial cooperation, support institutional relations, promote European GNSS in multi-GNSS context. And so this is our team. What you see, you heard Rainer, who spoke just now. Hannes is, of course, coordinating the whole event right today. And also there is Stephanie Pride. Then we have in Asia, myself and Ravi Kumar in India. Then we have also my counterparts in Taiwan, South Korea, in China, as well as in Japan. So this is our team in Asia. So what happens is that when you look at different organizations that we work with, some of them are bilateral organizations in those countries, and in India, it's our organization, Investment Innovation Research Alliance, that is a partner and driving the engagement and relationships in this particular project. So we've done a lot of events. As you can see, almost 60 events, and this is in Europe as well as in Asia. So Asian events are for European delegates to participate, and European events are for Asian delegates to participate and build relationships and bring about collaboration between each other. And also, if you see some of the other programs that we do within this ambit is also something called the GNSS-asia Challenge. So it is like, selecting winners. It could be hackathons. It could be winners of competitions and challenges that we run. So you can see 2 of the such challenges for which prizes were awarded. Then back in India, in Bangalore, we did a very big event in March. This was the hackathon, Galileo Hackathon, the first of its kind in Asia. And we had about 80 teams and universities participating, and we selected the winners. As you can see at the bottom, these were the participants who were there physically in the March event. Then you can also see the kind of engagement that has happened between the industry, European industry, as well as the industry in Asia. So you can see some of them like in countries like Korea, China, Taiwan, Japan, and India. So in India, we have been engaged with not only large corporations, but also with SMEs and startups. And when we talk about the whole program, you also look at what has been the success or the outcomes. So here you see one such collaboration that happened on the platform between a company called Teleorbit in Germany and Elina Geosystems, that's an Indian company that was incubated out of IIT Kharagpur. And they entered into a partnership where the technology was licensed from Teleorbit to Elina Geosystems. And then they got first customer, that's what you're seeing here. This is a company called Jindal Steel. So this proves to you that we can bring about collaborations on this platform, and then there are other opportunities that can emerge from it. In terms of numbers, as you can see, there are a number of events that have happened on your right side, where the industry cooperation is there. You can see 21 seminars, roundtables, 100+ registered companies. So you can read all these numbers. So what has happened is that the engagement has been increasing every month and year after year as we go forward, as we introduce newer engagements and newer programs for everybody to benefit. And what we also do for you, so for those who are joining us for the first time, what we can do is these are the various values we create for you: networking and matching support, dissemination, marketing support, market entry support. So we have helped companies from India to go to Europe, and likewise from Europe to come to India, as well as from Europe to rest of Asia. And not only that, within the Asian countries as well. For example, for Japanese companies to come to India, Indian companies to go to Taiwan, for example. Some of these other work that we do is in terms of reports. We create a load of communication between various stakeholders. We also produce this kind of reports that is to do with GNSS profile for, let us say, for different countries, as you can see from this pictograph in front of you. We've been creating reports year after year, and we have been also updating it. And we also have a website where you can visit and enter your requirements, whether it's a request for a collaboration or you are looking for some new technology. So we'll be able to bring those partners for you. And so this is GNSS.asia, as I said, and you can visit our website. There is a lot of news that is published every month, as well as interactions and opportunities for you to collaborate with us. And with this, I will hand over now this presentation to Dr. Anindya Bose, who is going to talk about the technical aspect of collaboration between NavIC and Galileo. Over to you.
Thank you, Varad. Hi, this is Ravi here. My name is Ravi Kumar. I'm working as a manager at GNSS.asia. So now, without further ado, we will turn the time over to our presenter, Dr. Anindya Bose. I would like to give a brief description about him. Dr. Anindya Bose is working as a senior scientific officer in the University of Burdwan and a senior member in URSI. He is an alumnus of National Physical Laboratory in New Delhi and International Space University, Strasbourg, France, and recipient of the URSI Young Scientist Award, a fellow IET India member, and ASI and IGNSS member. His research interest includes global navigation satellite system, microwaves, antenna, and communications. He has completed several sponsored R&D and manpower training projects. He is a convener Industry Institute Partnership Cell at the University of Burdwan and is a consultant for GNSS industry. Thank you, Bose, for accepting our request, and we are pleasure to have you here. We would like to love to hear from you. Over to you.
Can you hear me? Hello? Okay, hello?
Yes, we do.
Yes, Anindya.
Hello. Can you hear me now? Can you hear me?
Yes, Anindya, we can.
Can you hear me?
Yes, please go ahead.
Just, Good afternoon, everybody. One to all from Burdwan. It's a very small university in Calcutta. So thank you very much, GNSS.asia, for giving us an opportunity to present before you and to meet old friends. I see many friends here. Peter is here. I see them, and also the GNSS session, with which I had the opportunity to. So till the presentation comes from. Okay, since after is some disturbance in the in my connectivity, we are trying on the whole team to give the some bits. So Ravi is started screen sharing. Hello. So today my topic is using GNSS technology, Galileo and NavIC, as already been told. And next slide, please. Next slide, please. Hello, Ravi. Next slide, please. Okay. The disclaimer was like that all the views presented here would be of mine. Neither the University of Burdwan or any other agency is responsible for my views presented here. Okay. So today's agenda would be like this, that we will start with multi-GNSS signal environment from India, the Galileo and NavIC, a very brief constellation structure and the differentiators, what are being offered by the two systems. Then I will come about Galileo and NavIC visibility from India, what is very important for the users to use the systems. Then we will jump into Galileo and NavIC hybrid operation advantages from signal availability, satellite geometry, and solution quality viewpoints. Then another very important topic, that is the compact low-cost Galileo and NavIC devices modules, which are important for application development until and unless the users and the system developers have something cheap, very small, with low power consumption. Many applications cannot be developed. It is important. Another very important topic which is coming very fast is handheld devices, GNSS. I'll talk about, and ultimately we'll finish with the commercial application. So on the, you can see point I will consider longest all the points I have presented here. Ravi, next please. Ravi, next slide please. Hello. Okay. So advantage India and advantage Asia. So we are living in a multi-GNSS environment. I'll talk just after this slide, I will talk more about this. But in the top, you can see there is a simulation result which is presented by Multi-GNSS Asia some time ago with 30-degree elevation mask. That means no satellite below 30 degree will be used for solution purpose. And they have used all possible GNSS or RNSS components. For example, GPS, GLONASS, Galileo, Compass, IRNSS, QCSS, everything they have taken together, and the simulation result in the center, it shows that the Asian region, specifically India, is one of the hotspots for getting multi-GNSS signal environment. And coming into real life, on the left-hand side of your screen, you can see a real screenshot from Western India last June. There are 54 satellites in view, and out of them, 45 are being used. We have used GPS, GLONASS, Galileo, BOSE, NavIC, and QCSS. And on the right-hand side, you can see from my place, from the Eastern India, there are 54 satellites in view. And as because we have not used that for solution, we have just the information that for 54 satellites. So the point is, from breadth of India, from east west, from east to the extreme west, got at least 50 satellites always in view. And then what we see, we have it is from GNSS Android-based apps. It's yesterday data just from in front of my house. You can see only 30 satellites. At least 30 satellites are seen where I have in my street, houses and trees on both sides. But still, we can see 30 satellites. So just read our basic idea of geolocation that we need at least 4 satellites for solution. So we were at one point of time, we used to talk about 4 satellites to get our PVT, that means our position in three-dimensional coordinate system. And now we have at least around more than 45 satellites, always 45 satellites for use. So next slide, please, Ravi.
Dr. Bose, 1 second. I'm getting requests from the audience. Speak a bit slowly because they're saying because the connectivity is bad. So if you speak slowly, they can hear. Thank you.
Okay. Okay, thank you very much. Only my students will understand. Okay, so coming into the real scenario once again. As of 10th June 2020, if you take data for the different global systems, what is the scenario? The scenario is for GPS, there are 32 satellites in the orbit, out of them 30 are orbiting. In case of the Russian GLONASS, 27 are in orbit, out of them 23 are in action. And for Galileo, there are 25 satellites. Out of 25 satellites, 22 were in orbit. On 10th June, yesterday, there was an Nabu, so that it will be 21 if you see now. And for Medu, 48 satellites are 44 in action. And we go for the regional system. For QGSS, it's 4 out of 4, and for our own system, ISS is 7 out of 6. 6 out of 7 they're rating. So coming to the world map, if we see that now we can see over the globe, there are all the GNSS or RNSS systems, and above it, in this particular map, the SBAS system, satellite-based orbital systems, they are also added. So we have got presence of this type of satellite-based systems for the applications completely over the globe. And most interesting point is what I have marked in the bottom box, that when we get into the situation in 2020, the total number was 120. Now, if you add them up, 30, 23, 22, 44, etc., you will come at okay. So it is fascinating. It is fascinating that over the last say 6 months, 15 extra satellites, they are now operating. So I will throw before you to all the audience who are somewhere or the other are either interested or is involved or in deeply involved in GNSS industry, their applications, etc. So mostly for the students and for the researchers, I'm throwing this question that what from a country like India, we have got at least nearly 50 satellite signals for our use. How good we are using, or are we capable, or are we ready to use the advantage of a multi-GNSS satellite environment for the benefit of the country, for the benefit of the society? That is my first question, which I put before you would start asking the questions at the end of this presentation. I want to play a bit safe. Okay, next slide, please. So, and then I will just give you a glimpse on the growing GNSS market. On the bottom of your screen, probably you can see the links. The question was, somebody asked a question, so how good we are capable to utilizing the huge space asset and all the signals from the space for the benefit of the country, for the benefit of the people, and for the benefit of the progress of the humankind from our point of view. That is my question. Now, coming into the growing GNSS market, I've taken all the figures from a very open document, GNSS Market Report, issue 6, which has been published in 2019. You can go through it. It is readily available in the GSA website. You can download and go through it. And there I only want to put before you the total business volume, what is expected since 2019 to 2029. Next 10 years, what would be the business volume? So if you take on the left-hand side, bottom, you can see the total business volume is expected to be 2.5 billion euros. And other than this, the other part, a small part is other, where all these maritime, critical infrastructure, manned aviation, spacecraft, geomatics, main part is agriculture, drones, etc., etc. All these things are there, and that too, the total business volume is 170 billion euro. So, Ravi, please go. Slide. Ravi, next slide, please. Okay. No, it is before this one. This is the next slide. Yes. So here you can see I have not included my own heading of the slide. What I have done, I have taken this snapshot from this particular document and put it there. And just want you to see this one. Asia Pacific will continue to account for more than half of the global GNSS installed base. That's all. Don't look into other parts. Only look into the bottom part where different types of application has been proposed. But coming in the top, so you can very well understand for a country like India, there is a huge scope where the business potential of GNSS can be exploited, can be mass market solutions can be developed, that they can be taken into the market, and they can change the life of people. If time permits, at the end, I will give you some examples. What, due to my connection with GNSS.asia, by visiting different hackathons, excellent type of ideas we came across, and if time permits, I will try to share with you. Ravi, next. Okay, so the GNSS market macro trends. Once again, all the document has been taken, all the figures or the pictures has been taken from the same document, and I got no better document than to convey this idea to the participants. Here the main points are, I will just tell about the central ideas, the IoTs. Obviously, that they have their use in smart city. Secondly, a combination of these technologies, IoT applications, different GNSS market segment, and IoT solutions and applications. So they're coming together. So just like human being, as the time has come due to the COVID situation, we have to collaborate and co-create. Similarly, this type of technologies, we have to, the challenge is to put them together and create more and more solutions that is more applicable and more required for the society. One of the other things is big data. The other possible candidates are the UAVs and the drone market. And till now, I have not touched the M-health or mobile health aspect. So till now, before this COVID-19 situation prevailed, we had slightly a bit of idea, and many of us, including me, were a bit skeptic about the M-health idea. But now I don't have to tell anything, or don't have to try to make somebody understand what M-health means and how it can change the life of people. So these are the GNSS market macro trends where lots and lots of work we've done, and people have to work together. Next, Ravi. So this is the Galileo space segment. I'm sorry, on the left-hand part, there's a small video that how the Galileo constellation looked like in 3 orbit, 3 equally spaced orbits, plane in medium Earth orbit, around 29,000 kilometer height, inclination 56 degree. Each plane contains 8 slots occupied by baseline satellites to a 24 satellite constellation and 2 spare satellites in each plane. So that is the basic, I would rather say the very baseline idea. And there are few satellite classes: Galileo in-orbit validation assets, then IOV, and full operation capability satellites, which are now transmitting the signals, and lots of people are working on this way. I don't want to recite more on the topic because it's all public document. Anybody interested can go to the websites, or I will give you smaller websites where all these type of documents or all the type of informations, they're clustered together. So using SDK, we have done the simulation, and that was the visibility of Galileo from India. We have taken it from Hyderabad. So let us come about the Galileo services. So the Galileo services, firstly, the freely accessible service for positioning, timing, and navigation message authentication, and they come under the service class open service. Okay, then encrypted service designated for greater robustness and higher availability. They comes under the public regulated service (PRS). Another very important topic is assisting of locating people in distress, and confirms that they're getting help. The help is on the way. So he or she gets confidence to fight against the situation. Then freely accessible high accuracy positioning service, what is called the HAS, and authentication service based on the E6 signal code encryption and OS NMA navigation message authentication, allowing for increased robustness of professional application. I will talk about this just after. Ravi. Okay, so if we try to put together the Galileo differentiators, so the basic 3 differentiators are Galileo dual frequency. Now they're operating in E1 and E5. So because of the dual frequency, you can see there are 2 case studies, one from broadband. So the red dots, you can see the red dots are using a single frequency, and the blue dots are using a dual frequency. So you can very well understand they're using dual frequency. On the right it is given, may not be fully legible, but I want to give you the idea that when we use 2 frequencies, because of some technical aspects, because I do not have enough freedom to go into that, but still ultimately we get better solution if we can use 2 signals together for a system. And that has been introduced in many of the GNSS systems, but still now Galileo is forerunner here. The number of 2 frequency transmitting signals, number of satellites are larger than the other counterparts. Second is the high accuracy service. The high accuracy service in different phases, this is being implemented so that we get decimeter level accuracy. And very important part is the authentication. The authentication, now the GNSS signals, all the GNSS signals, they are prone to intentional or non-intentional disturbances. And in case of intentional disturbances, the satellite, the signal are played with by unscrupulous people, and ultimately the position solution degrades, and even that can lead to catastrophe. Those of you who are interested, they may search in the internet for New York, NEWARK, New York Airport case. A typical case can be seen here. So authentication is required so that the user has clear idea from where the signal is coming. It is a real signal, or it is a signal being transmitted by those people who want to hack me or who want to put me into trouble. So this type of authentication service are being introduced here in phases, and that will be very important for the critical applications. And ultimately, it's our research that we get reference is given at the bottom, that Galileo signal strength we found is much stable than the other satellite constellation. It is just in the threshold of publication, it has been accepted, but it is a new finding what we got. We studied GPS signal, tolerance signal, and Galileo signal, and we found that stable signal strength, which is very important mostly for the small module manufacturers, so that their units do not lose lock very fast due to the stability of the signal. So these are the differentiators. There are many, it's an open document. There are many open documents you can suggest that, but these are the main points why you wanted to focus before you. Next, please. So I want to show you a few very recent use cases. For example, Galileo Return Link Service, it was successfully demonstrated in January 2020, where a person in distress, when he or she is sending some distress signal, and that is taken up by the Galileo satellites, and that is sent back to the emergency response team, and through return link, the emergency response team confirms him or her that, okay, we got your message and we are running fast, do not worry, do not panic. So that may save a huge number of lives. Second, another very important application only over the last couple of months, in May and June 2020, it is being implemented, that is Greenland for movement of critical assets from one country to another in a COVID-19 situation for authentication. It's a very beautiful application. So making space for the oceans, a very large project, I would say, how to use Galileo along with the SBAS signal for improvement of quality of life towards a green environment. And more examples you can find in the GNSS market report, over which you will find the Horizon 2020 logo, and many test cases are there. So researchers present here, they can pick up a few ideas, what may be useful for a country like us, and they can start working. So it can be the, I would say, the seed for your thought process. So that's why I thought that I should present this one. Next, please. Okay. Now let us come about our own system, the NavIC or IRNSS, navigation using Indian constellation or Indian regional navigation satellite system. So it's a completely different type of constellation. What we teach in our normal GNSS class, that it would be a MEO satellite, ensemble of MEO satellites like that. So here, it is a 7-satellite regional constellation, which consists of 3 inclined GSOs and 4 inclined GSOs into orbits and 3 geostationary Earth orbit satellites. So you can see here, this is a very basic idea. In the next slide, it will be more clear. Once again, we created using STK the visibility of NavIC satellites from Hyderabad, nearly center of India, and how it's looked like. Next, please. So, on the left-hand side, what we have given, what is the coverage area of NavIC? So NavIC coverage area, it has been declared to have 2 phases. One is called the Central Service Region, which consists of 500 kilometers from the 105 kilometers from the geographical boundary of India, that is marked in the figure with green lines, and with the red line, that is called extended service region, which varies from latitude 30 degrees south to 50 degrees north, and longitude 30 degrees east to 130 degrees east. And you can see from the figure that it is marked in dotted red color, and you can very well see that it covers a part of Africa. And you can see for this part, this particular satellite always would have a very, its location just above the head, that means in an navi position. So is the case for the countries in the Far East. They have got the presence of at least 1 satellite overhead. And these are the, another one is at 83 degrees east. This is the geostationary satellite. And in the IGSO orbits, these are the 4 satellites, they have got complementary visibility. So because they are confined within a very small region of the Earth, and as because we want to give regional service only. So because of due to the relative position of the satellites on the in their orbits, sometimes creates, here we are trying to give the worst situation. If you can see, So the two IGSOs, they're here, and these two child IGSOs, they're there. And for the best situation, we can get a best situation where the geometry is best reflected in terms of bit of precision, dilution, or precision. Another important point is the incorporation of the S-band along with L in case of NavIC, and in the differentiator, I will talk about that. Next slide, please. Okay. Another very, very important message, important service, what is being provided, quite similar to that of Galileo, that the NavIC alert message service. The NavIC alert message service, it continuously gives alert messages about cyclone, tsunami, high tide, and along with that, potential fishing zone for tuna and other fishes. And ISRO's this system, it is guiding the fishermen from Kerala. As you see, it's a clipping from one newspaper. They are given the handheld devices so that when they goes into the sea, they can get alerts for this one for safety of their life and property. And obviously, during normal period, they can find out the fishing zone very easily, and so that they can rush there, get their catch, and come back to the safety as fast as possible. So in the bottom, you can see already a few companies, Indian companies. It is from Citisalit, who are going to be our education partner. Yeah, they have developed the Marino device for the fishermen. There are many other companies who are coming up with the solutions. And on the right, you can see this is a desktop utility, what has been developed by us. The whole thing we can see. So this is a real life picture. A few weeks ago, Amphan, a very serious cyclone hit the eastern part of India. And this is the case when it is in the warning stage, not in the danger state. And similarly, on the bottom, you can see the fishing zones. They are being shown on the map so that fishermen can rush in there and get their catch. So that is, I would say, a life changer for a large number of people who are dependent on fishing for their livelihood. Next slide, please. So if you look into the NavIC differentiators, so NavIC differentiators signals from high elevation angle over the service region. So you can see here, although a bit light, I've taken it from one of my papers. So the papers are referred below. So you can see if there is no NavIC and the system is operating within a constant environment, on both the sides, flats are there. So we are getting only 3 to 4 satellites. So if one of them misses, we will not get 3D solution. But if you bring in NavIC, so we are getting at least 6 satellites, so that always the possibility is extremely high to get solutions. And how it helps, I will come across afterwards. Second differentiator is the S-band signal, higher horizontal solution accuracy. Once again, we got this one, the gray one. You can see the S-band signal. So it is once again from a very recently developed published paper from us. And most interestingly, enhanced jamming and interference protection. Many of you who deal with this protection issue, they know that now 200 to 600, 700 rupees interference generator, intentional interference generator are available. Simply put into the cigarette lighted adapter in your car. It will transmit some jamming signal, and we have checked about 25 to 50 meters, all GPS receiver stops operation. But what happened in that case? Still now in the market, there is no S-band jammer, because the market is still now very, very small. So we have the advantage that even if the L-band is completely blocked, we have S-band signal to block it out, to bail us out from the situation. And the third differentiator, what I want to put before you, that as because there are satellites in geostationary orbit, they move only a little bit, and the same signal can be accessed from 2 different parts of our country, and The same signal, when they studied, we got certain signatures. We took data from Panhala, Western India, near Kolhapur, and our place in the Eastern India. So we studied the same signal at the same instant of time from two different places. But you can see one dark line and one lighter line. The dark line is for one place and the lighter line is for one place. That means the local disturbances very easily can be investigated for the interested stakeholders, mostly those are engaged in the atmospheric research, S-band, and this type of constellation structure gives them certain advantage over the previous case where the satellites always keep on moving. Okay, next slide, please. So if we look into the GNSS visibility for the service region, you can see with 10-degree elevation mask angle, always in the gray area, 7 satellites are always visible. And from the graph, you can see only in the extreme 2 parts, always NavIC-based solution is possible. We are increasing the elevation mask, that means no satellite below 20 degree would be used for solution. Still, you can see over this region, many countries other than ours, they can get the benefit of this one, that at least all the time 7 satellites are there. Here 5 to 7 satellites there. So standalone NavIC solution is possible. So what we are doing next, we are increasing the elevation of mask angle. We are sort of simulating a condition where both the sides are blocked, and myself or any other user taking a NavIC receiver in a narrow lane or in a narrow road. So on the both sides up to 30 degree, no satellite signal is available. So at that time, you can see 6 to 7 satellites, nearly 7 satellites are always used here. And other than the blue portion, here at least 4 satellites, what is the basic requirement for solution that is available. And that will help the countries here to have an alternative or a parallel system which can be fused together with any other GNSS for better solution accuracy. Next one, please. Okay, we have tried NavIC from different parts of the globe. We have tried from Saudi Arabia. We have tried from Tokyo, Japan, courtesy Tokyo University of Marine Sciences. They trained our students, and during the training, they did this work. And also during one of the Multi-GNSS Asia conference last year, we took the GNSS receivers to Bangkok, and thanks to our friend from NMIT Bangkok, they gave us the opportunity to collect data from there, and we collected data there for Marister and Elena small modules. And here we have used the Alistair module in case of Japan, and here we have used the Skytrack module. I will talk all about this afterwards. Next slide, please. Okay, so these are the results. Just skip this one. Just skip this one, really. Okay. So why Galileo and NavIC taken together? Why we were interested about this? Number one, both the systems are managed by civilian authorities. Both have unique civilian applications. They operate in common band. They have got similar signal structure and potential complementary benefits, what I will present just next. The next one. Okay, so we got a GNSS visibility issue for India. The case is we took GPS, GLONASS and Galileo data continuously for 5-6 days from Burdwan, and we found that during some part of the day, it happens that even the black line is all the satellites taken together. All the satellites, the maximum elevation angle of all the satellites in each constellation, it goes beyond 60 degrees. The case is shown here. Okay, and remains there for certain time. So if you add them together, even then you get a period of time nearly 40 minutes, and then it repeats every day some 40 minutes and 23 minutes we get data case. The next question is obviously, so what's the harm? So what's the harm? It happens. So we took another example. So what we did, we took a motorbike mounted IGS receiver, which can track both GPS and NavIC. And we took the GPS receiver during this affected period when there is no satellite above 60-degree elevation, and we moved through a path in our small city, a congested path, buildings on the both sides, and you can see that solution quality is degraded. Some of them, some solution locks are there, because sometimes when signals are completely, signals from the low elevation angle, they are completely obstructed by the houses, and there is no signal above 60 degree. So we have got only a patch of the sky from where we can get signal. And if the number of signals becomes lower than 4, there is no lock. And even if there are 4 and they do not have a good satellite geometry, the satellite geometry will be poor, resulting in such a situation. You can see in affected period, their scatter is much more. But in case of normal situation, the quality, solution quality is better. Next slide. Okay, we did this experiment. So this is the affected period, no satellite above 60 degree. So you can see the solution spread. And this is a normal condition where some satellites are above 60 degree. And you can see here the solution success rate in this case falls to 93.6. And just bear in mind that we are using GPS, GLONASS, Galileo together. Even taking 3 systems together, this is the case. So if we fully depend upon, next slide please, if we fully depend upon a single constellation, what will happen? So we simulated this for a complete globe, and on the left hand side, this is the case. The red dot means this is the point where at least 20 minutes over a day, this problem occurs. And this is for GPS, GLONASS, Galileo, that there are many places over the globe. So Galileo covers this part, GLONASS covers this part, US covers this part without any problem. But for other parts, mainly in the low latitude region or mid latitude region and their polar regions, the problem exists. So how to get rid of this? Next slide. So we did a research. It has been published here. The link is at the bottom. So we have seen that in case for India, because of the typical structure of the IRNSS constellation, always at least 55 to 60 degree above that one, always at least one satellite is available. So that takes care of the problem. Always we have got a satellite on the top, and in the below we have got 3 to 4 satellites. So altogether we have got 4 to 5 satellites, so that there would be no loss of solution and the solution quality at least improve a bit. And when we added up this GPS, GLONASS, Galileo, NavIC together, you can see, if you recall to the previous picture, that this part was affected by this problem, but here now this part gets rid of because of the presence of the NavIC signal. If we add up QGSS, we have done that. That will also take care of another larger part of the globe. So the solution is once again work together, cooperate. So if we can bring together a GPS, a GNSS system, a global system, and a regional system, this type of problem we can get rid of that, and we come out with the solution with our result. Next page. So this is our first experience with Galileo. In 2013, we made the first Galileo 4 satellite solution, 3D solution, and reported it to the European Space Agency. And they have given us a template that we are among the first 50 users of Galileo. It was good news for us, and that enhanced our interest in Galileo. Next slide. Okay, now what we did, we had a few in-house developed softwares. This software is called GSLP, GNSS Satellite Visibility Simulation Tool. So using this visibility tool, we can create a visibility pattern of any constellation from any point on the surface of the globe with any elevation mask. I can take the observation point XYZ, and from that one, run the simulation, and we have to download the 2-line element files, current 2-line element files from the internet, and it goes. So what we did, we took a few points on the boundary of the primary service area, right? And we took a few points on the boundary of the extended service area. And we tried to see what are the visibility patterns or what are the number of Galileo and NavIC satellites they are present there. Okay, on the bottom side, the dark ones are the Galileo satellites, and we have taken the data every 4 hours, 08 hour, 4, 8, 12, 16, 28, 24. So this data we collected, we simulated and put it together. So if you see here, in the central part, you can see during this type, so 4, 8, 12, 6, 0, 4, 8, 12, 16, around 16 hours IST with 15-degree elevation mask. Here you can see here in the eastern, from center to center to the southeastern region. The problem is that Galileo has a bit lower visibility. Okay, that I will show in through another figure. So if we add, and in that case, the IRNSS visibility is very good. So if you put them together, so we would always have 8 to even 14 satellites for use, always in this part. And in the western part, the Galileo satellite visibility is much better than the IRNSS. Here the IRNSS visibility is fixed 3 to 4. So in this part, IRNSS is supplementing Galileo. In this part, Galileo is supplementing the IRNSS. So a good handholding would always be beneficial for the users, and most importantly, those people who are coming up with their solutions. So those people say they're using only NavIC or only Galileo, so they may be in trouble in some cases. So if it is a Galileo-NavIC combined system, it would be better for them, so they can be very, very confident about getting the solutions always. So this is what we found out and what we are going to present. It is ready to communicate. Maybe next week, these study results we will communicate. Next slide, please. So what happens with the satellite geometry? So here you can see on the top, we have provided 3 sky plots. Here the GPS only, it's in open sky. It is Galileo only, here it is NavIC only, and here NavIC plus Galileo together. In case of Galileo only, you can see 1, 2, 3, 4, 5, only 5 satellites, and most importantly, this one is not being used. Most importantly, 2 of the satellites, they are providing a signal from very near or in the same region from the sky. Those who are acquainted with the satellite geometry ideas, you can very well understand that would lead to not so good PDOP. Once again, in case of IRNSS, they are clustered only in the southern part of India or the region. So once again, they have got in standalone operation, they have got certain satellite geometry issue. But if we put them together, so this is the case. You can see, so even here in the southern hemisphere, there is only 1. If you take this one, only 2 satellites. But if you put them together, the southern hemisphere is being complemented by IRNSS. And in case of IRNSS, the northern hemisphere or the northern quadrants, 2 quadrants, they are being supplemented by Galileo. I think I can communicate to you that a good handholding would be beneficial for both the systems. So coming down for the, here we have shown the maximum elevation angle, what we have shown for a long time ago in 2017. And this is a current data of May 2020. So the black one is for Galileo maximum elevation. The red one is for NavIC geo satellite, which varies a very little angle. And the blue one is for the Galileo NavIC GSO satellite. So if you take them together, you can always see where there is a Galileo satellite which is going below some obstruction. The NavIC satellites is supplementing it. And in other cases, the Galileo satellites from very high elevation angle is helping to improve the geometry of the whole situation in a NavIC Galileo mode. Next slide, please. Next slide. Hello. So if we look into now, if we look into the satellite geometry and the previous one, please. The previous one. If you look into the satellite geometry and signal strength, once again, it's now very clear that as in a hybrid operation, there would be large number of satellites scattered over the sky, so that DOP would be good. And once again, from 24 hours data in May 2020, you can see that. So this is the NavIC DOP variation. So the gray one is the Galileo variation, and the black one at the bottom, you can see when we are using NavIC plus Galileo, we are getting a much better geometry, and geometry directly affects the accuracy. So we expect to get better accuracy. And next, once again, if we look into the signal strength, the red one is NavIC and NavIC PRN, and the black one is, the red one is Galileo and the black one is NavIC. In case of NavIC, the advantage is has stronger signal, but it has got much variation. As I already told, that Galileo signal is very stable. And here in this case, you can see it is very stable. So stability of Galileo signal and strength of IRNSS signal, that can be a value addition for both of them, and for low-cost application development, this can help in coming out with good quality solutions. Next. Okay. Now, what happens in the solution quality? So what we did, we used our reference point. Reference point we have calculated out using Leica GR50 and AR25 Chokring antenna, and we used OSPOS online PPT service. Using that one, we created our reference point, and on the basis of the reference point, we used a Java Delta multi-GNSS receiver. So in the first experiment, what we did, we took six Galileo satellites were visible at that time. We continuously kept on increasing number of NavIC satellites into solution sequentially, keeping the bit of value more or less similar. I cannot say same. So you can see that 2D average error comes down. Similarly, it comes down, and the 2D standard deviation of error, it is once again, you can see it is coming down. So it is very clear from this particular experiment that if we can add NavIC into the Galileo solution, the hybrid Galileo-NavIC solution would be improved. And we did standalone NavIC, standalone Galileo, and Galileo-NavIC. We took 1,800 epochs using the very same infrastructure with a very good quality antenna. And here you can see definite improvement in the 2D RMS, CEP, and also in case of 3D solution, SEP and MRSE values. You can see that they are improving, and what is expected, and also through our experiments, we could see that. Next slide, please. Now, the other problem is if somebody wants to use Galileo and NavIC. So what are the way outs? So where they can get the signals? This is just for, because lots and lots of information one can get if you search the internet. Lots of information are there. In case of GPS, Galileo and NavIC, various server grade receivers are there. These are just non-exhaustive list. Many other manufacturers have their products. So on the left-hand side, it is Java. They are both Galileo and NavIC L5 enabled. So is the case of Leica. But in case of Leica, you cannot run it on NavIC only mode. You have to use it in GPS plus NavIC. But still, they can track NavIC. And third is the Trimble alloy. What is found from their technical documentation that they are capable of using L5 plus S together. I have not used Trimbles, just my idea is from their data sheet. But still another problem is low cost L-band plus S antenna. You can very well understand that the market is limited. So lots of R&D efforts has to be put to come out with a very broadband antenna that can cover L and S band of microwave frequencies. So still now it's I would rather say it's an open challenge. Now the most important receiver, surrogate receiver, what we obtained through a MOU with SAC ISRO, and they have given us these receivers to use and to develop solution and to do research. It is L5, it is developed by ISRO, and it is L5 with the help of Accord. It is an L5 plus S receiver, and it has got a typical different type of antenna. At the same time, we have got record and replay systems and replicators, rest logic, Rest logic, it can record Galileo and NavIC signals, and it can be played back, coming back to your laboratory. If you have any other receiver, you can play it back and do your own research, which one is giving a good solution, which one is better than that. So for this type of research, this is a very good instrument, but very, very costly, you can very well understand. And second is the devices from IP Solutions, a company from Japan. So these are the surrogate receivers, what one can use. But once again, this is a non-exhaustive list, many other manufacturers, and I would expect with very good quality products there in the market. I shared my experiences with you. Next slide. Okay, well, over the last couple of years, maybe 2, 3, 4 years, the game changers in the GNSS scenario is the compact, multi-constellation, now multi-frequency, low-power consuming receivers. I repeat, compact, low-power consuming, multi-constellation, multi-frequency receivers. Okay, and their power requirement is very, very low. How it looks like? It looks like this. Say, for example, I have given the red ones are the receivers or the modules, what we have used ourselves, and the black ones are, we have not used it. We have taken the collection information from the internet, from the manufacturers themselves. So if you take the Skytrack GI3, Skytrack GI2 and GI3, they are the first this type of modules came in the market. They have got 56 channels. They are GPS and NavIC L5 enabled receiver. They are not Galileo enabled. But we started our journey with low-cost modules. You can very well understand the survey-grade receivers are very, very costly. And that cannot be accessed by everybody who do not have much support, government support to go for this type of infrastructure. But these ones, they're more or less low cost, maybe $75, $100, or even less than that, even some $50 EVK boards. I'm not talking about only the chipset, I'm talking about the EVK board. So the researchers, universities, colleges, they can straight away take the board, add up the antenna, and attach it to their computer and start working with this one. So these are the first is Skytrack. So Skytrack very recently came out with a different chipset family. It has got 230 channels. It is Galileo enabled, but not NavIC enabled. And second point is it is RTK enabled and dual frequency. Already, as I told, the dual frequency helps in getting better solution. And RTK is a method, because there is no scope for discussion. RTK is a method using which the accuracy enhancement of a rover receiver can be done with the help of a base receiver. So it's sort of a commercial use. There would be a base receiver. It is a differential approach. A base receiver will receive signal. It will calculate the errors and transmit the errors for the users to use. The users within a limited geographical region from the base station, they will take the data and use the error signals to nullify their errors so that the solution quality improves. So RTK is a bit different than that one. It uses carrier phase-based measurement, but is a very, very useful tool. What is being used nowadays worldwide for very low cost applications. For example, I can give you my base station is a survey-grade receiver costing around $20,000 US, and my rover receiver, which I am putting in my car, in my tractor, in my ambulance. There may be any one of them, maybe U-Blocks M80 or Skytrack module or U-Blocks F9P, so this cosmic receiver or Alistair module. We can put it, it will be a RTK receiver. It will take the RTK data from the base, improve its solution, and in a very low cost, give us a better solution than what earlier we are getting. So another very important and very popular chip is U-Blocks. From U-Blocks M8P, it is a 32-channel receiver. It can use Galileo, but not NavIC. It is RTK enabled, but not dual frequency. The next version in case of U-Blocks is F9P. F9P is a bit costlier than the, I would say nearly 2.1 times costlier than the previous chips. U-Blocks F9P, it is a, most importantly, it is a RTK enabled dual frequency receiver. So in standalone operation, the dual frequency gives it better solution, and in RTK, The RTK gives its better solution. So these are the very important parameters, important candidates to watch for and to try for. Then comes Alistair Tau 1202. Tau 1202 is a I'm sorry, Tau 1202, there is an error. 1202 is not NavIC L5 enable. 1205 is NavIC L5 enable. I repeat, 02 is Galileo enable, not GNSS NavIC enable, but 1205 is Galileo and NavIC enable, and it is dual frequency. And it is in very small form factor it comes. Next slide, please. So now the others. So other manufacturers here are Telit, 48 channels. Interestingly, they can use both Galileo and NavIC. We have used them. Then comes Quicktale. Quicktale is a NavIC L5 receiver, but the cost is very, very low. A very newcomer in the market is UTrack. It has got 48 channels. It can use NavIC L5, also GPS, as because we are talking about Galileo. I'm not talking about that. So UTrack is another solution. So now I will talk about another product, Elena B2B. It is a Indian product. The B2B you can see on the left-hand side, and B2D, what we have not used, that is on the right-hand side. It has got 128 channels. It can track Galileo, NavIC, and NavIC-S. I repeat, NavIC-S here. It is a dual frequency receiver. And the newcomer in our laboratory, we got it just last week, that is NTLab AP104. It is a, once again, it is NTLab 104. Once again, a 128 channel receiver. It is GPS, GLONASS, Galileo, everything. So here we are concentrating on, it is a Galileo enabled, NavIC L5 enabled, NavIC S5 enabled, RTK enabled, and dual frequency enabled receiver. So it's a very interesting device to start working with. We're just waiting when the lockdown is. Still now we are lockdown. So we will start working this one, and probably we are extended hands together to each other so that we can form a collaboration. And ultimately, I will present before you our own module. It's a 4x7 centimeter module. We call it GLB01. It is just like other modules what you are seeing, nothing extra. Only thing is we have designed we have designed it ourselves, and it is working fine. And we are in the process of multiplying the prototypes. It's just like that. Add up your antenna and connect it to your computer. Run a software. I'm talking about softwares. Which software one can use. Next slide, please. Okay. Now these are the I would say bit high-end type of except Accord Navica. All other are a bit high-end type of I would not say modules, but OEM boards. All these things I have taken from their data sheets. I have no experience of using them, so all of them are either green color, no red entry here. So the manufacturers are Septentrio, Mosaic. I expect to be a very, very interesting module because it has got Galileo, all other constellation, NavIC. It is RTK enabled, dual frequency enabled. So Maxim, very hard to difficult, more information. I got the information from the third-party seller. Similarly, Hexagon, PIM 7500, etc. Novatel OEM 7720 series, and obviously because of Navica 550 here, just because of only one point, that is there were no space in the previous slide. That's why I took it here. No other reason. Okay, please. So we can see here that lots of low-cost hardware are available, which can be directly purchased from the Indian market or maybe imported. And people who are interested in working in NavIC and working in multi-GNSS environment, they can start working with this type of modules, which maybe before 1.5 years or 2 years, we had to always depend upon only the surrogate receivers for our research. Next slide, please. Okay. Another very interesting idea is Android phones for GNSS. I put it in this way, Galileo and NavIC on Android phones. I've taken this slide from my good old friend and teacher, Professor Renato Fischer. You can see here in Google Location API 23, up to this one, only raw data, the NIMA data can be used. In 24, the raw data can be collected. Okay, so next slide, please. Next slide. So you can see there are different levels of apps. Using those apps, either we can see the how it is performing, what is the instantaneous location, what are the satellite information, etc., etc. But we cannot log data. In level 2, we can record NIMA data. So these are the example apps, and this is one example on the right. You can see while I was moving from Kolkata to Bangalore, I took the data using NIMA Pro, and afterward we put it on map, and you can see it's giving quite good result. So it's a very new topic. Next slide, please.
Dr. Bose,
yeah.
You know, how many more slides? I thought we'll also go into Q&A.
Okay, I will finish up first. So there are Android-based applications, what you can see like there. Next one. Next one, please. Next one, please. So another thing is now we can get raw data. Here is an example. We can get raw data using GNSS logger, and there is a software called GNSS analysis app from Google. You can download it here and analyze your raw data. It's a very interesting idea. I would request here everybody to go through the link I have given in the bottom. Those who are interested, they can read learning here. And if you are interested, maybe in some other platform or in this platform, we can discuss this thing in much more detail. Next one. And it will be a very good tool for the user, geospatial community. The next question, NavIC-enabled Android phones. Are they available? Yes, the answer is NavIC-enabled chipsets are from Qualcomm and Huawei. And on the left, I have taken a few phones which are hitting in the market. Already they are hitting the market. Basically from Realme, Redmi, Xiaomi, Honor, Huawei, like that. And these are the links from where I have collected the information I have given. And the golden question for people like me, with older devices receive NavIC support some patch through a software update? I'm sorry to say the answer is no, it is not possible. So next slide, please. So these are the application areas where we can work together. Mainly in case of agriculture, digital farming, agri-product logistics, manure, irrigation, livestock. In case of wearable safety devices and ITS, disaster management. In case of COVID, we have seen many possibilities are there for management of the situation, and environment monitoring. So I see from Indian point of view, these are the these are the very important aspects where we can put our efforts and come out with solutions for the people. Okay, next slide, please. So we need GNSS toughening and augmenting. So the problems which are already there, we have to take care of that, and we should come out with a secure GNSS position, navigation, and timing output. So I've taken the data from forward and to put it from GNSS inside GNSS. Next slide, please. So what is needed at the end? We need networking and matchmaking, industry, research, academia, synergy. The word cooperate to co-create in this situation where we are separated in distance, and definitely government level support to all the consortiums. We need to disseminate sensitization through demonstration, exhibition, webinars, roundtables, and at the end, in the innovation, challenge and research scope, that has to be taken care of, that has to be taken by the young researchers who are presented here. NavIC Galileo interoperability issue, so that we get better solution. The S-band antenna design and fabrication, the interference and, sorry, I cannot see due to the pop-up. Interference jamming, spoofing mitigation, a very important aspect. NavIC for atmospheric research and society-related application development. And last slide, next slide. So this is I would request you to visit our website. We have got a reference station, entry service, the surrogate receivers, compact GNSS modules, and we have got a few custom developed softwares for GNSS data recording and processing. Next one. So these are our work areas: exploring multi-GNSS, NavIC, cost-effective compact GNSS modules, low-cost GNSS-based application, use of Android-based handheld devices. And our services are entry, teaching and training of researchers. Last year we taught 12 students from different parts of the country, collaborative research, and we can provide support to industry for testing and validation. So next slide. So thank you very much. So this is our team. On behalf of our team, we convey our sincere thanks for your attention and interest, and our acknowledgement first to GNSS.asia and then to our sponsors and patrons, Space Application Center, AICT, and DRDO, within which we have developed our infrastructure and working on this one. And Dr. Banerjee is our consultant, and you cannot see over the presentation, but in a static mode, that's me, Anindya. So thank you very much. Now, if you have any question, Ravi, over to Ravi.
Thank you. Thank you so much, Dr. Anindya Bose, for this great presentation. Now we will go into the questions. So we have a few questions already. One question that has come up is, how can we use NavIC data on GIS software?
Should I take all the questions and answer, or I will answer one by one?
You can answer one by one.
So thank you, sir, for your question. Obviously, what you can do, you can use this type of modules, this type of small modules, collect your data, and even in level 4 and level 5 apps, directly you can take the data into your mobile. You do not need a computer. So take the data, come back to your laboratory, use data processing, simply data churning software, and come out with your solution, develop a KML5, and then attach it to your GIS applications. It is quite, I'd say, a bit long, but quite easy. Even our students in geospatial applications, they have learned from us, and also we learned from them that how to integrate that. It is quite possible. First, you have to collect data. You can depend upon your mobile phone or an external device which can be connected to your mobile phone over Bluetooth or cable, and run a proper application that will collect data. And you can send it to email to your control center. In the control center, very fast they can churn out the data, put it on your GIS layer. That can be done, and our students work on this one. And if you're more interested, please contact with us. We would be more happy to learn from you and to give you some support.
Okay, the next question is from Hemu Joshi. What is a PPP enabled receiver? Is it better than RTK?
Well, the answer is PPP enabled receivers, they should be dual frequency. They should have capability to get RANX data. And after collection of data, you have to use either a real-time data processing software, for example, GLab, or any other commercially available software. Or what you can do, you can upload the data. There are many online data processing softwares. You upload the data there, free of cost, depending upon the queue. They will do the PPP for you and give it back to you. Still now we have used, only for creating PPP points, we have used surrogate receivers. And we are in the process of using at least the dual frequency receiver, for example, F9P and the Alistair receivers. Whether that data, the raw data, what they are providing, using the raw data, because both of them are dual frequency, can we do PPP using this one? But still now it is very early to comment. But for PPP receivers, you need a surrogate receiver, which are costly, and you need to know the steps how to do it.
Okay, thank you. Next question is from Arup Dasgupta. Is it that most consumer devices are using only L5?
Yes.
Is it that most consumer devices using only L5?
Yes. Still now the in Indian market, as far as my knowledge goes, all the consumer devices which use IRNSS, they use IRNSS L5 only. Because just if over the last couple of months, two receivers which I have shown you, that one is Elena from India and the second one is NTLab from Belarus. They are developing S-band GNSS receivers, so that can be used. But the other challenge is, still now in the market, in the readily available market, you can purchase a L-band receiver as low as a good quality commercial receiver as low as $20. But as because the customer base is very, very low, the S-band receivers, what obviously you will give it to your customer. So for the customer, your hardware solution is 10,000 rupees. But for your customer, the antenna is maybe 30 to 60,000 rupees. It's a no solution. So another challenge lies development of our indigenous low-cost L plus S receiver. When it is done, I think the market will open up because of those many applications and advantages. So people will start working using both L5 and S. But as of now, all of them use L5 signal as far as my knowledge goes. Thank you.
Okay, thank you. So next question is from Srinu. So is there a support for external IMU measurements to the evaluation boards you have shown? Any experiences with IMU, please share.
Okay. You have to think about the cost lines. The cost line is most of them comes with under INR 5,000. That is, I would rather say around 50. Around 60 to 70, $65. So in $65, if they want to put together the IMU, it will be very difficult for them. But already in the market, a bit higher cost IMU enabled devices are entering into the market. Or I would rather suggest, I know you are a researcher, so why not you start working with you purchase because uBlocks have got many IMU units, many manufacturers, they have got their IMU units. So why not you take this type of two modules and try to develop the low-cost solutions, obviously low-cost solution, so that it may be a compact solution. So as of now, the low-cost receivers, they do not have IMU solutions. But the higher-end receivers, what I have shown you, higher-end, not the sub-end, higher-end OEM receivers, some of them are incorporating this into their modules. What I have learned from their data sheets. Thank you.
Thank you. Thank you, Dr. Bose. The next question is from Pratik Singh. Why ISRO uses S-band NavIC, knowing Wi-Fi and other devices using the same band, that is 2.4 gigahertz?
Okay, this issue came up, but I think that has to be taken care of. Exactly, when we know there is some problem, if there is any, in the problem in the road, I do not stop walking. I simply take proper precaution and come over with that problem and reach my destination. So I see it that way. As a researcher, I always see it in that way. And that answer can be given by ISRO only. But as a researcher, I use both L5 and S. I know about this type of problem from literatures, but I don't bother because I know how to take care of this. The problem is 10% and the advantage is 60%. So at the margin of 50%, I am always ready to use the S-band signal, even if they have got those type of issues. Because other differentiators, what the S-band is providing before us, that is quite good. So that is my answer for Mr. Prashmita. Thank you very much.
Thank you. So the next question is about the analysis and results of Galileo plus IRNSS, both for your reference location or anywhere in general.
Pardon?
The analysis and results of Galileo plus. Hello, can you hear me?
I can hear you.
Hello.
Hello.
Yeah, the analysis and results of Galileo plus IRNSS, both for your reference location or anywhere in general. So he's asking, is it in general the data that you showed, Galileo plus IRNSS, is it general or is it only for your reference? where you did
Okay,
the research, your location.
Okay, we use the reference location only for one purpose. That in other cases, when we want to study the precision parameters, 2D RMS, etc., we have to take the average value as the reference. But better that we have done this type of analysis using our reference location, which in the horizontal coordinate is accurate by 3 millimeter by 4 millimeter. And we kept on checking that. So what happens once we do this type of validation with a very well-known reference and with high degree of confidence, we can tell that our stakeholders or other stakeholders or other researchers, they can also, we can inculcate some confidence among them that, well, it has been tested for a reference location, it would be valid for your location too. It is valid, it's a general thing. Because we have physically tested, real life data we have tested, then we have simulated and tested. So that's why our results take a long time to come out. So repeatability is our, I would say, main point. Until and unless we become very sure, we do not go for anything for publication. So we repeated it. And we have also used low-cost modules, but the results are under processing. That's why I could not present that one. So it is a general. If you use good quality receiver, good quality antenna, your quality would be better. And obviously, in case of small receivers and commercial antennas, it will be a bit worse. But you have to keep in your mind whether you are getting the cost versus benefit advantage. At one part you have to pay 20,000 US dollars. At one part you are spending $150. So which one solution is serving your purpose? That you have to first find out and then select the hardware. And the results are true for everyone.
Thank you so much, Dr. Bose. There is another question about Google geolocation API. Does it give combined with the data of all constellations, the Google map? So I hope you're able to see this question. No? Does Google geolocation API give combined data of all constellations?
Right. Well, that's a problem. What has been discussed in the 4th GNSS raw measurement task force led by GSA, and of course our university is a member to that one. It has been, because not only that, suppose what I have shown you, that we have tested 10 mobiles with different Android versions and different apps. And we came across that it is not, till now, it is not fully controlled by the user. It is fully controlled by the UI of the particular phone on which it is running. That which particular, can you go back a few slides, please, where I have shown a result? Just a few slides. Few slides, please. Can you go back? Go back, go back, go back, go back, go back. Or one more, this one. So what we did, no, the previous one. What you are showing, the next one. Yeah, no, the next one. Yes, this one. So you can see here on the left-hand side, we have taken mobile phones from our friends, from researchers, and put together 10 phones. We kept them. There are different problems. We kept them on our rooftop and take data for 30 minutes. And after taking data for 30 minutes using our software, we processed it. And you can see here, say for example, Xiaomi Note 5. It is taking GPS Galileo Glow. Xiaomi A2, the same thing. Xiaomi Note 4, it is taking GPS plus GLONASS only. Similarly, if you come in case of Samsung J600G, here it is taking GPS, BDS, QSS, and GLONASS. Even then, you can see the values of 2D RMS for 30 minutes data, simultaneous data. You can see the values differs. One thing is they depend upon the Android version, and second thing is they depend upon the UI of the particular phone. So still now, we cannot control what constellation we are taking. Only thing is, if you, in the previous slide, you may see one extremely good software app, what is development by the GNSS. It is called the Galileo PVT, and we kept on complaining and requesting them, why not you are accommodating all the satellite signals here? Why only GPS and Galileo? There you can see the satellite status for all the constellations. But for the positioning, only GPS or Galileo or GPS plus Galileo is used, and enemy data can be logged there. I would tell everybody just to try Galileo PVT. And in future, in the Indian market, many dual frequency phones, dual GNSS frequency phones has been launched, tried with Redmi K20 Pro, and you can try something like how in the same position a single frequency phone and a dual frequency phone, their performance difference like that. But unfortunately, I should have waited for a few more months so that I can purchase a K30 with NavIC support. In case of mobiles, it always happens like that. So we'll be waiting for a NavIC enabled phone to extend our research in NavIC arena also.
Thank you.
So thank you,
Dr. Bose. And I must say, now we have completely run out of time. And so there are a lot of questions still not answered. My suggestion is that we have a section on GNSS.asia website. Please approach us there, and we will be able to answer all your questions. And, I have now with me Hannes, who would like to, talk about some of the plans we have. And he will also give the closing words. Over to you, Hannes.
Thank you very much, Varad, and thank you so much, Dr. Bose, for joining us today for this enlightening seminar and workshop. Thanks everyone also for joining us today. As Varad rightfully mentioned, we always have things ahead of us. Currently, in terms of events, due to the coronavirus crisis, we do not have any physical events planned so far. Nevertheless, we intend to organize more webinars to come in the next few weeks and months. One of them will again focus on India, on specific industry use cases. That will be for after this summer. But first and foremost, there is, besides the events that we organize, more to read on our website. Since this year, we have a complete GNSS innovation blog focusing on different GNSS markets in Europe and Asia. And we have guest contributors there sharing the latest and greatest on how they use GNSS technologies. So definitely go for a read over there and enjoy it over a cup of coffee or tea. Besides that, we're currently working on our market and technology trends, focusing on each GNSS market, including India, and these should be published within the next 2 weeks. So definitely go to GNSS.asia, select India or Europe, depending on the market which you'd like to read about, and register for our newsletter. As soon as our market trends are available, you'll receive these exclusively, and you'll have access to the PDF where you can read the latest and greatest on GNSS in Europe and Asia. That's it from my side. I would again like to thank Professor Bose for joining us, but also our Indian team, who's doing excellent work, present from Bangalore and across India. Last year we had a great hackathon, and we hope that as soon as the COVID crisis is getting better and behind us, we'll be able to see you all physically again for a roundtable, for maybe another hackathon in India, or hopefully even also for a cup of coffee to discuss our shared passion of satellite navigation technologies. So have a great evening and afternoon, all of you, and I wish everyone also an excellent health in the time to come. Thank you.
Thank you so much. Thank you, Hannes. Thank you, everyone. Please collaborate and co-create. Thank you so much. Bye-bye.
Thank you so much. Thank you very much.